Hello there, my name is Osama, and today we are going to talk about a survey I constructed. And as you can see, the topic of my survey is middleware for systems in robotics, a reflection of ongoing development in middleware design. Today we are going to talk about autonomous robots and their distributive systems. Well, before we start, I would like to define what do I mean when I say autonomous systems or autonomous robots. Well, autonomous robots can be defined as the category of robots which can work on their own, thus having higher complexity in their system design. Well, as we move towards the prospect of having more intelligent robots, it would be there to say that the complexity will rise. And here, our goal is to reduce that complexity and at the same time making it robust by reducing the complexity in the system and by making it more accepting towards hardware and software changes. Start by thinking that there must be something that we can do to provide this feature to the system where we can find a solution, probably a layer that can lie in between both hardware and software system so that whatever we do to hardware and software and the changes that occur in both components or any one of them can be easily accepted by the system, thus maintaining the high level of developmental efficiency and at the same time making system more flexible towards new components. We can actually introduce this layer. We call this particular layer middleware, and basically it's a bridge between both hardware and software layer. As you can see in the figure, it lies in between application, and we can say like it lies between the hardware and the software component. Well, that leads us towards our problem statement. Well, I could say for our problem statement is to like design a technique that offers experimental capacity to ease the growth of a robot system while ensuring that it can deal with changes in hardware and software component as we talked about in the last slide. At the same time, it should be independent of language. So the user, if he knows any sort of language, he would be able to develop and design a new system for robot. And it can communicate with other middleware with no additional coding. Well, as we move forward, we would be able to see more middleware layers. And our motive is to find a communication bridge that can move from one middleware to another middleware so we can use the resources that we have, and by using the combination of those resources we can have a better system utility. Now, as I talked about middleware layers, we have several middleware layers here to discuss. So we have OpenIDK, Miro, Orin, sensory data processing middleware, distributed humanoid robots middleware. Now, every middleware is supposed to have these common features, and we are expected there. Well, basically, there is no standard. I would say there are no standards for middleware layers, so there are some objectives, some milestones that every middleware layer can achieve in order to be called as an effective middleware layer. So, as you can see, we have cost reduction, one time effort for building new components. That is, you build a component, and then now that you have this component, you can use it over and over. That ensures reusability of software and hardware components. At the same time, you would be able to use your own component with other components which were pre-existed in both layers, in software and in hardware. Now, we as middleware layer solution is a great solution. At the same time, we have communication complexity here. It, it was noticed during the survey, it was noticed that middleware layer oppose, or I can say that it shows some reluctancy towards proper communication. You would not want to end up having a middle layer which doesn't provide easy communication, where you have to write more code to bridge the gap between the communication layer of two middlewares. Now, moving on. Some middleware showed that there was an improper utilization of the resources, that they were, it was really difficult for them to utilize all the resources. That means their lack of management, and you would not to have a solution which would not use the available resources. Now, moving on. The developers of such middleware layers were not inclined towards putting in a lot of efforts for security. Well, in order to overcome the problems that were presented by middleware layer use, we came across this solution. Well, it is called Intelligent Cross-Platform Interface, where the solution basically provided to rectify the problems mentioned came from middleware layers. Now, there are some features of ICPI. Well, it actually allows you to cross-platform data parsing, data probing, definition of data labels and unit systems. It is better to use ICPI because it can provide you data and software management. So remember, we were talking about software utilization. Now here, because of having this feature, data and software management, well, I would say data and software component resource management, they have this feature. Now, it has common data structure and protocols, which can ensure that across all the middleware layer we use in through ICPI, we would be able to communicate easily. It also has self-modularity for core components. Now, towards the end, I would like to say that middleware layer provide open source solution for the hardware software integration, which is I would say a dream for a software or hardware developer. But at the same time, middleware layer solution lacked the robustness and ease of use, because you want a smooth operation when you develop something, and you once you have some resources, when you have some components written, you would like to use them over and over, and there is still work required for those middleware solution to come up with something, a new solution, or probably the new version of, or the at like the improved version of what we have these days, that can assure that it would be easier to communicate across all the middleware layers. And as we talked about ICPI, it's a nice step towards that option or that solution. Yet it still needs some time to fully develop and act as a system, act as a solution that can provide us better resources, better solution, so we can actually make our distributive ro- robot systems more robust and at the same time make them more redundant. And by redundancy, I mean they are more acceptable towards the changes. We have more solutions, we have more ease and comfortability. So, with that, I would like to say good luck to you guys and thank you for your attention.